This example is like problem 3 in the exam review. Here we have a simple random sample of 125 individuals. That is our sample size n. And the sample mean, that's x bar. The sample mean number of robocalls received per day was 4.2. So x bar is 4.20. And we're assuming the population standard deviation is sigma is 0.84. We are going to first construct a 99% confidence interval for the mean number of robocalls received per day and round to 2 decimal places. So 99% confidence interval means that our alpha is 0.01, and so our alpha over 2 is 0.01 over 2, 0.005. So here's our confidence interval formula. We've got sigma, we've got n, we've got x bar, we need z alpha over 2. So z alpha over 2, remember, is the z value with that area to the right. So you use inverse norm to get areas. So r alpha over 2 here is 0.005. So that means if you look at that z value, it's over here, and it's got 0.005 is the area to the right. So inverse norm uses left areas, so 1 minus 0.005 is 0.995 is the left area. So you want to do inverse norm of 0.995. And then mean and standard deviation by default are 0 and 1. So let's compute that. So second variables, inverse norm number 3. Area is left area, 0.95. Let's see, 0.995. Mean and standard deviation, 0 and 1 by default. Paste it and enter, 2.576. So if you want 3 decimal places there. So now let's go ahead and do our plugins here. So our x bar value was the 4.20 or 4.2. So we've got 4.2 minus the 2.576. And then times sigma is 0.84. And we are dividing by root n, which is root 125. And let's go ahead and do the upper, which is going to be 4.20 minus 2.576 times 0.84, I'm sorry, plus 0.2576 times 0.84 over root 125. So now let's compute that margin of error on the calculator. So we've got 2.576 times 0.84 divide by square root 125. So 0.1935, we want 2 decimal places, so 0.19. So this will be 4.20 minus 0.19. which is 4.01. And then down here, this is again 0.19, so 4.20 plus 0.19, which is 4.39. So lower limit and upper limit for our interval. So we would write that interval as 4.01, comma 4.39. So we're 99% confident that our population mean number of robocalls is between 4.01 and 4.39. So, and then if we check this on the TI-84, we can go to stat and then tests, and then we want z interval, which is number 7. And we are using not the data, but the summary statistics, so highlight that. Our standard deviation for the population, 0.84. Our X-bar, 4.2. Our sample size, 125. And then our confidence level was 0.99. And then calculate. So 4.0065 to 4.3935, which is right here. And that is agreeing to 2 decimal places with what we did. Part B, what if the sample size were 100 rather than 125? Would the margin of error be larger or smaller than in Part A? So our margin of error in Part A was 0.19, and that margin of error in general is the z-value times sigma over square root of n. Well, if we use a sample size of 100 instead of 125, that means that we're using a smaller value of n. So this denominator is going to be smaller. It's going to divide into the top more times, so that sigma over root n is going to be larger, right? The bottom of the fraction decreases, so the ratio increases. So then the sigma over root n is larger, so then once you multiply it by z alpha over 2, the alpha over 2 sigma over root n is going to be larger. It's going to increase. So the margin of error here would be larger. Since a decrease in sample size, see, right, we decreased from 125 to 100, will increase the standard error, that sigma over root n, and that's what we were saying up here. The standard error gets larger. So this part gets bigger, so the whole thing gets bigger since the z-value stays the same. Now, if that didn't make sense, you could just substitute 100 in your calculator and see if the interval gets bigger or smaller. So we could go to Stat and Tests and do z-interval again, number 7, and just change our n down here to 100. And now our interval is 3.98 to 4.41. So 3.98 to 4.41. And we can see that this is a bigger interval, goes down farther and up farther. So that means that your margin of error is increasing. Margin of error larger here. If the confidence level was 90% instead of 99, would the margin of error be larger or smaller? So 90% for confidence level means that alpha is 0.10. So alpha over 2 is 0.05. And then your z alpha over 2, z 0.05. Now your left area is 0.95, still 0 and 1 for mean and standard deviation. And if you key that in the calculator, you'll get 1.645. And so what's going on there is that our z-value here has gone from 2.576 down to 1.645. So it decreased. So the z alpha over 2 decreases, which means that z alpha over 2 sigma over root n also decreases. Because this part stays the same, this part gets smaller, so the whole thing gets smaller. So the margin of error would be smaller since a decrease in the confidence level, we decreased it from 99 down to 90, will decrease the critical value. So it decreases our critical value of the z alpha over 2. And then part D, based on the confidence interval in part A, is it likely that the mean number of robocalls per day is more than 5? So, well, our confidence interval up here, 99% confidence interval, let me bring that down, was 4.01 to 4.39. So that means that 99% of samples are going to give 99% of samples are going to contain our population mean. And this is one of the 99% of samples. But notice that 5 is not in this interval. Okay, so 5 is not in that interval of 4.01 to 4.39, but 99% confidence means that 99% of the intervals are going to generate confidence intervals containing the mean. So containing mu. So if your mu was 5 here, that's not in there, and 99% of the time it is. So it is not likely that the mean is 5 because it's outside that interval, right? If you draw the picture here, we've got 4.01 up to 4.39, and then 5 is up here. It's outside the interval. Well, 99% of these intervals contain the population mean, so it's not likely that that's population mean.